Simultaneous equations is a set of two or more equations, each containing two or more variables whose values can simultaneously satisfy all the equations in the set. Today in this video, we are going to specifically talk about one linear equation and one quadratic equation. This is an example of a linear equation, and this is an example of quadratic equation. So how are we going to find the values of x and y so that both the values of x and y can satisfy both the equations? So first of all, we are just going to make y the subject for equation 1 to become like that, and we call that equation 1a because it's related to equation 1. And now, since y equal to 2x minus 3 and y equal to x squared minus 2x plus 1, and both the y values are the same, so that means 2x minus 3 is equal to x squared minus 2x plus 1 because y values are equal. So equation 1a is equal to equation 2, so that this happens. Now we are just going to group together like terms to become like that. X squared minus 4x plus 4 is equal to 0. Now you can see that we can factorize this, so this happens. X minus 2 squared is equal to 0, so x is equal to 2. This is an equal roots or one repeated root of this equation. X squared minus 4x plus 4 is equal to 0. Now we are just going to substitute x equal to 2 into equation 1 just to find the y value. So we are just going to do that. So y plus 3 is equal to 2 times 2. So y is equal to 1. So the values of x and y, so that it can satisfy both of the equations, will be x is equal to 1, y is equal, x is equal to 2, y is equal to 1. So let's look at another example of simultaneous equations. And this time we are going to involve some fractions, but it's almost similar. The method is almost similar. So we're just going to try it out. So we just call this as equation 1. This is equation 2. And since the y values are the same, we are solving simultaneous equations, we are going to let equation 1 is equal to equation 2. So this will happen. 3 over 2 plus 2x minus x squared is equal to half x plus 2. And now we're just going to move everything to one side. So we're just going to add x squared, minus 2x, minus 3 over 2, minus 3 over 2. So on the left hand side, it will be 0. But what about on the right hand side? On the right hand side, you have x squared, and half x minus 2x will be negative 3 over 2x. And this is 2 minus 3 over 2, which is plus 1 over 2 is equal to 0. Okay, now I don't want it to be, I don't want my quadratic equation to have fractions, so I'm going to multiply 2 on both sides just to get rid of the denominators there. So now it will be 2x squared minus 3x plus 1 is equal to 0. Can we factorize that? I think we can. Yep. 2x minus 1 multiplied by x minus 1 is equal to 0. Just to make sure. Yes, it is possible. So now we have x is equal to half or x is equal to 1. So it seems like we have two sets of solutions. So when x is equal to half, we are going to substitute x equal to half into the linear equation, which is 2. So let's do that. So y is equal to half times x, which is half, plus 2, and that is equal half times half is 1 over 4, plus 2, which is 8 over 4, and that is 9 over 4. So when x is equal to half, y is equal to 9 over 4. What about when x is equal to 1? We are now going to substitute x is equal to 1 into the linear equation once again. So y is equal to half multiplied by 1 plus 2, and that is 2 plus half, which is 5 over 2. So we can conclusion. So when x is equal to half, y is equal to 9 over 4, x is equal to 1, y would be 5 over 2. So we will have two sets of solutions that can satisfy both equations at the same time. Now if you look at it in terms of graph, this is a quadratic curve and this is a linear straight line that is going up like that. And this is of course a U shape. There will be two intersections between this line and this quadratic curve. Okay, so I thought that I'm going to compare with this example with the previous example, because now this is no longer 3 over 2, it is 1. So in terms of curve, I just bring it down just a little bit and see if there are still two intersections between this line and this quadratic curve. So whether there's intersections or not, we'll prove it. So once again, we're just going to call this as equation 1. And this is equation 2. And now we are just going to let equation 1 is equal to equation 2 because the y values are the same. So 1 plus 2x minus x squared is equal to half x plus 2. And now we are going to plus x squared minus 2x minus 2x minus 1 minus 1. And now on the left hand side will be 0. On the right hand side it will be x squared half x minus 2x minus 3 over 2x 2 minus 1 plus 1, and that is equal to 0. And once again, just to get rid of the denominator, I'm going to multiply both sides by 2. So it will be 2x squared minus 3x plus 2 is equal to 0. Can we factorize this? This is plus, so no, I actually don't think so. I think we can't factorize. So I'm going to use the quadratic formula. So a is equal to 2, b is equal to negative 3, the coefficient of x squared, the coefficient of x is negative 3, and c is equal to 2. So now we use the quadratic formula. X is equal to negative b, which is negative 3, plus minus negative 3 squared minus 4 times a times c. And I'm just gonna square root that. And then the whole thing divide by 2 multiply by a, which is 2. So this part will be 3 plus minus, this is 9 minus 4 times 2 times 2, 16. Oh, I saw some problem here. This is 4. 9 minus 16 is a negative value. X minus 16 is negative value. I'm just going to finish writing that. But we can't square root a negative value. So we can conclude that there will be no values of x. So that means we don't have any solutions. There's no value of x that can satisfy both these equations. So there will be no solution. No values of x and y can satisfy both these equations. So by bringing down just by half of the quadratic curve, there will be no solution. Compared to last time, we'll have two solutions. Interesting.